So as you walked in this morning, you picked up 3 different pieces of paper. Okay? The first piece of paper that you picked up was labeled note sheet 3-2, I believe. It was labeled population growth problems. That's this one. This one is what we are doing today in class. Okay? So we're going to complete that one today in class. So keep that one handy. The second stack, you got a 2-sided note sheet, 3.3 note sheet. We'll talk about that one momentarily. And you also picked up a pink homework packet. Okay? So those are the 3 things that we talked about. So today, we're going to complete that very first one, the 3.2 note sheet. Okay? You will also have the opportunity today in class to start the pink packet. Now, if you'll notice on the very first page of the pink packet that there is an issue. Anybody see said issue? So we did the first homework for you. So there's that. Okay? All right? So it says sketch the graphs for the directions, and then we put the answer key on there. Oops. It happens. Okay? This is what happens when Mrs. Hill isn't here for 2 days. Okay? You leave it up to Mr. Roth and I, and we start throwing out softballs for you. Okay? All right? So you can do pages 1 through 4. We did pages 1 and 2 for you. So there's that. Okay? So you can start on that. Then the 3.3 note sheet, that's what this number 3 here is all about. Okay? So prior to Tuesday's class, so this is the last class of the week because we have a Warrior Day tomorrow, so no class meeting tomorrow throughout the day. Okay? So starting, and I will make the videos go live soon, and probably by the end of class they'll be live. Okay? So you're going to complete that note sheet. So you can do it from memory. That's one way of doing it. You can watch the 3.3 video on Canvas. That's the part that hasn't been published yet, but it'll be published soon. Or you can read section 3.3 in your textbook, which is on Canvas already. Okay. Or Ross said you can just Google, YouTube, search it, and all that fun stuff. Okay. But it is your responsibility to know the information on that 3.3 note sheet by Tuesday, because we're going to use that information in class on Tuesday. So if you don't like being lost, you got okay. Any questions on those? So let's talk population growth. Okay? So suppose the population of San Jose is following an exponential growth pattern. In 1990, the population of San Jose was approximately 782,000 people. And in 2000, that grew to approximately 895,000. Okay? Let's create 2 ordered pairs from the given information. Okay? Can somebody can somebody make me 2 ordered pairs, please? Yes, ma'am.
0.
Would you be okay if I just went 782? Is everybody good with that? And we just, since they're both in thousands, we just drop the thousands. Makes our numbers just a little smaller. Okay. All right. What would the next one be? Somebody else. 10 and 895. Okay. So using that data, now we need to find an exponential model in the form P of t is equal to A times B to the T, where T is the time in years, and A represents the initial population when T equals 0. Okay? So, do we know what A is? If so, what is it? 782, right? Because the A is defined as represents the initial population when T equals 0, and we set T equal to 0 right there. So A here would be 782. We just need to find B. Now, how do you think we're going to find B? Okay, so what am I going to plug it into? Or what equation will I be using?
So it would be like 895 equals 780.
Can you hold on 1 second? Apparently there's too big of a conversation going on in the back of the room for us to learn math right now. Are we done? No, if you were sorry, you would have been quiet. Continue.
So it would be 895 equals 782 times 2 to the 10th power.
Do we all agree with that? Okay. So given that, oops, sorry, I need to be in a different color. So 895, you said, equals 782 times b to the 10th power. Given that information, please take this time to solve. So first I would divide by 782. So that's going to give me 895 divided by 782 equals b to the 10th power. And then I need to take the 10th root of both sides. So that is going to give me b is equal to the 10th root correction. 10th root of 800, what would you say, 895 divided by 782. And that will give me approximately 1.0135 for my B value. 1.0135. So my equation then would be 782 times 1.01359. More decimal places is better in this case. It'll give us a more accurate graph when we need it, or an accurate model. Okay, so we're there. Everybody good through that one? According to the model, what would our approximate population be in the year 2005? Find that for me, please. What year is 2005? 15. Okay? So we need to find for year 15. So if we do that, then we can plug in 15 there, and I get 957.483. Now I use the answer. So basically, if you mind the way I did it, I put in this second of the negative key, and it takes whatever the exact answer. It took the 10th root of that. Now, if I would have done this, oops, escape, 782 times 1.01359 raised to the 15th power, it would have been very close. Alright? So 957,000, you want to go 506 or 483? .483 is more accurate because it's using more decimal places. Okay, so 957,483. Now, in this next problem, it says sketch the graph of our function, growth or decay. Growth, okay, all right. Horizontal asymptote. Still y equals 0, right? Exponential growth. What is that point right there? 0,782. So we can label that one of two ways. We can say that we could label that point, or we could say that this level here is 782. Then we went out to here, we put 0. Then we went out to about here, correct? And so then this point would be 10, and we would be at how much? 895. Okay. Then we went out to 15, and this was at, we'll say 957, right? Now that's your axes labeled in numbers. Okay? It said we had to label our axes in words. So vertically, what would our label be? Population. Horizontally, what would our label be? Years since 1990? Okay. There will come times this year in the pre-calculus where we are going to have you sketch graphs like this. And we're going to say, right next to that, label your axes in words and in numbers. The most common mistake in pre-calculus is people just give us the graph. They don't label their axes in words and in numbers. Okay? You've got to put some kind of context on your graphs. Okay? Love it. Now, before we get to that one, let's put this very graph onto our calculator. So I am going to open up a second page. Control Doc gets me a second page. Then we are going to be adding in a graph. That graph is going to be our function, 782 times 1.01359 raised to the, this time I've got to go with x, even though in our two problems ago we labeled it t, because my function here is a function of x. Now, when you hit enter, you are not going to see it. Okay? Because your window is only going up to 6.67. So we have to adjust our window accordingly. Anybody remember how to adjust the window? Or we could do it in a much simpler way. The window settings, you remember how to get to them? Menu. Which one do you think? If I want to adjust my window settings. Window/zoom. Which one do you think I'm going to want to go for window settings? Window settings. Now that's going to give me a chart that I need to fill in. So let's talk about this chart here for a second. X's are what again? Horizontal, and what was it in our graph? Time in years, right? Okay. So do we need to be -10? Probably not, right? Okay. I, on the other hand, like to see my axes, so I'm going to go -5 there. Okay. Then, maximum. Is 10 enough for my maximum? No, because we went out to 15 already, right? Okay. So 30, sound good? 30 years out? I'm going to go with a scale of 5s only because then I said it. You know what I mean? It's not some goofy like decimal. Okay. Y's. What was our Y's again? Population. Okay. Now, I like to see that axis, so I'm going to go here with, and it's going to be kind of goofy because you're going to say, why are you doing this, Lynn? But again, I like to see it. I'm going with -250. Okay. Maximum. What do we think for a maximum? But not a million. It would be like 1,000, right?
Yeah.
Okay. So we could go 1,000 here. And then my scale here is going to be, I'm going to go back to 50s. And then when you hit OK, now you should see part of your graph. What's on? It's all like, you know what I mean? We don't have a lot. So what can we do to adjust that window? Which one do we have to adjust? Left, right, top, or bottom? No, I think we gotta adjust this one, right? Let's go 2,000 there. That look better? I like that. I like that. That looks a little bit better. Okay. So now we've got that going on. Okay. So now let's go back here into this, and let's answer these next question, or this next question. Assuming that the population growth continued to grow according to this model, in approximately what year did the population surpass 1 million people? Okay. Now, 1 million people on our graph is how much? It's 1,000 on our graph because we dropped the 1,000. So we need to put a second line on our graph, but this time it's going to be 1,000. We want to know in what year those two met. How would I do that? Menu, analyze graph, intersection, and we don't need to be cute. So get that area nice and wide so that you get an intersection of 18.2. Okay? So what is this saying right there? In 18 years, it's going to be 1 million people in San Jose, right? So 2008, okay? 2008, roughly February, March-ish of 2008. Yeah? Love it. What I would like you to do now is I would like you to do the Columbus problem, please. So I get in approximately January or February of 2010. Agree? Yes, sir. Yep. Good. For the remainder of the time, you can start working on the pink packet, doing the first 4 sides. Should be halfway done already.